Hello friends, welcome if you are new on our channel and welcome back if this is not the first time you are joining us. We are going to be continuing with our math lessons and we are going to be seeing solving linear inequalities in one variable. Inequalities in one variable means we only have one variable in the inequality. The same variable can be found more than once in the inequality, but it remains the same and one variable. So if I say x is greater than 7, my variable here is x and is one variable in the inequality. If I do also say 2x is greater than 7 minus x, I have x repeated twice in the inequality, but at the end, it's still x, right? And only one variable, which is x. So in this inequality, I still have one variable. Now, if instead I say x greater than 8 plus y, in this case, I have x, which is a variable, and I have y, which is a variable. And x and y are not the same, they are different. Therefore, I have here two variables. And for now, we are not talking about two variables, so this, we will not be seeing this. We will only be dealing with inequalities with one variable. So if I say y less than 4 plus 2y, I have y and y and y, they are same. So this I have inequality in one variable. In a linear inequality, the only operations that involve the variable are addition, subtraction, and multiplication. And for linear inequalities, we use less, greater than, less or equal, and greater or equal. An example is x greater or equal 3. Observing this inequality, we can say that 3 is a solution because we can replace x by the value 3 and we will have 3 greater or equal 3. And what makes this true is because of the equal sign associated to the greater sign. 3 equal 3. So because of the equals, this is true. Also, the inequality says greater or equals, right? Meaning any number greater than 3 is also solution. Saying that means for our inequality x greater or equal 3, x can be 3 and 3 is greater or equal 3. True. X can also be 3.5. 3.5 is a number and 3.5 is greater or equal 3. And we can have 4, which is part of the solution. We can have 5, part of the solution. 5.2, part of the solution. Any number that you can think of which is greater or equal 3 is part of the solution. So we will be having many solutions, and we can even say the solutions are infinitely many. Now that we know that some linear inequalities can have infinitely many solutions. How do we represent or how do we communicate this solution in order not to miss a number part of the solution, since we cannot list all these numbers the way we saw it before we start listing for 3 from 3, 3.1, 3.2, 3.3, 3.4 until 4, 4.1, and between 4.1 and 4.2 we still have 4.11. So you can imagine how many numbers, if you have to be listening them, you have to be writing them, we will not finish writing them, but we have at the same time to communicate the solution so that whoever sees it will know that we are talking about many numbers starting from 3 and to infinity positively. To do that, we use graphs, and this is just one way of representing our solution. We have many other ways that we will be talking about very later. To represent solution on graph, we will use the number line, and we saw the number line before. So for instance, if we have our x greater or equal 3 that we want to represent, we said that solution is any number greater than 3, and here include 3 because we have equal. So what we do is draw our number line. We can start from the origin 0, 1, 2, 3, 4, and then this arrow means we keep going, and we can have another arrow here means we are coming from negative infinite to positive infinite. We can have negative numbers as well. Here, our focus is on the 3 first. So we have 3 here, right? And it says x greater or equal 3. On the number line, what side of 3 is greater than 3? If we pick this side, any number I will take from this side will not be true. So it says greater or equal 3, so it will be this side, right? And we will represent our solution by shading the, the right side. So we add this one as bold as we can, right? As bold as we can. And we add another bold arrow indicating that we are counting our numbers to infinity. So we are counting, we don't stop, we keep counting. That's why we have this bold arrow. And on the 3 now, we will put this bold circle. And this circle is not empty. It is a solid, bold circle, meaning 3 is part of the solution. If 3 were not a part, just in parentheses, right? If 3 were not part of the solution, we will have represented it with an empty circle, so like something like this. So if you see this, that means the number is not par. But if you see a bold circle like this, very dark, bold, full, not empty, that means that number on which the bold circle is part of the solution. So just for you to know, for strict inequalities, meaning qualities where we have greater or less, they are strict. There is no equal part of them. They are greater, strictly greater, or strictly less. For this kind of inequality, the border value, which in this case is 3, the border value is indicated with an empty circle, as I said before, right? And for non-strict inequalities, and they are great or equal, less or equal. We represent the border point of this solid dot or circle because the border value is part of the solution. We will do examples and use some different methods to solve linear inequalities so you will be able to understand better. The two methods that we are going to be using to solve our inequalities in one variable are the test value method and the standard form method. So test value method and standard form method. We are going to start with the test value method. So if we want to use the test value method for graphing linear inequalities in one variable, we go through some steps. First, transform our linear inequality into a linear equality, right? We secondly solve the equality to find the value that we call border value. We next put on our number line the border value that we found. We choose at each side of the border value a test value that we test using our original linear inequality. We last, after test, determine which side of the number line we should shade as solution of our linear inequality. Also, we represent the borderline by its corresponding circle, open or closed dot, as we saw previously, right? Plain or bold, plain, empty, all that you can call it one to one, but one will be very dark and one will be a circle and the white inside. So we do that according to whether we have a strict inequality or a non-strict inequality. And we will do some example for you to apply that and follow along with what we will be doing. So let's do some examples. And the question can be graph all solution of the inequality. Let's say 3x minus 5 greater than x plus 2. Okay, so this is our question. We are going to answer it, and there are steps. First, what do? We transform our inequality into an equality. So 3x minus 5 equal x plus 2. What do we do next? We solve the equality to find the value that is solution, right? So we know how to solve linear equation in one variable. So we proceed. Plus 5 plus 5. This gives me 7. This is x plus 7. These two cancel. This is 3x. So now minus x minus x. This is 2x equals 7. These two cancel, so I have my 7 there. And now I divide by 2. I divide by 2. I have x equal to 7 over 2. Or if I can write it at 3.5, 7 over 2 is 3.5, right? Now, our is border value is 7 over 2 or 3.5. Can write it the way you want. And now, next we do our number line. 0, 1, 2, 3, 4, 5, and we will be going. This one also goes this way with negative numbers before the 0, and so on. So our border value, which is 3.5, we have is going to be between 3 and 4. So here is our 3.5, or 7/2. So now next step is to choose. We have two sides. This is our value. We have this side of it, or this side of, you choose any number that you can use, any number you can use. You just choose one of your choice, one side, to test the inequality. So first what we have to do is rewrite our inequality. 3x minus 5 greater than x plus 2. So I choose, you can choose otherwise. I choose, you start testing this with one number before the 3, so this side, right? And here I can choose any number. I will choose 0, for instance, 0. And you choose the number, you replace the x by the number. So 3 times 0 minus 5, is it greater than x plus 2? You can add a question mark here because you are not is not an affirmation, is a testing. So you put question mark at the end, and then you keep going. 3 times 0 is 0, right? I have 0 minus 5. Is it greater than 0 plus 2? Don't know yet. 0 minus 5 is negative 5. Is negative 5 greater than 2? What do you think? Is negative 5 greater than 2? No, no, false. Or I can say it's false, right? So, meaning this part of my number line is not the solution, not solution. So I repeat the same thing by using a number from the other side, this side. So I will go with 5. I repeat the same thing. 3x minus 5 greater than x plus 2. Replace the x by the 5. I have 3 times 5 minus 5. Is it greater than 5 plus 2? Question mark. Have 15 minus 5. Is it greater than 7? Question mark. 15 minus 5 is 10, right? Is 10 greater than 7? Yes. Or I can say true. So this side of my number line is solution. And now I put my bold line indicating the solution with the arrow, because everything right there will be solution. And at 3, I put what? What do I put? Bold dot or empty dot? Should be an empty dot, right? Should be an empty dot, because 3 is not part of the solution. Why? Because we have a strict inequality. There is no equal sign following the greater. So we have a strict inequality. So 3 is not part. So it should be an empty dot. So as solution, if I want to, a little bit messy, I want to represent my solution, I can just put 3.5 or 7 and do my bold line with arrow pointing that direction and my empty circle. So that is my solution. The second method that we will see is the standard form method, right? In this case, we use addition and multiplication to rewrite the inequality in the standard form. Standard form meaning that we will have the variable on one side of the inequality sign or inequality symbol by itself, mostly on the left side of the inequality symbol, and all other values on the other side, mostly the right side, right, of the inequality symbol. So in standard forms, we will end up having something like x less than a value or x greater than a value or x less or equal a value, and also or else greater or equal a value. So these are the solution, the potential or possible solution that we will have as standard form. And we proceed to representing the solution on the number line as we see before. Once we get to a standard form, the rest we do it. So how do we get to standard form? Let's do some example. So example, if I have x equal greater than 3, this is already in a standard form. So I just graph it, right? I do my number line. I have 3, and it says greater than 3. If I start graphing, after 3 I have 4, 5, 6. Before 3 I have 2, 1, 0. What side of the tree is greater? So you see, obviously the right side, right? So this side is greater. So I bold this side with an arrow, and then my tree is an empty dot because 3 is not part of the solution. So this was example 1. Example 2. If I have x less or equal -1, I still have one standard form already. So what I do is to my number line 0, 1, 2, 3, -1, -2, -3. And here my border value is -1, right? So -1, and here I have x less or equal -1, meaning -1 is part of my solution because I have equal sign involved. So first of all, I can represent this in a bold dot, and now any number less than -1 is solution. And what side is less than -1 is the left side. So I just do this with my arrow pointing this direction to indicate that we have infinitely many solutions. Are we following? If it seems or it looks a little bit confusing, you can just replay the video. If the given inequality is not given in a standard form, we perform operation to rewrite it in a standard form before graphing it. So let's say we have this question. They ask us to graph all solution for, let me call it example 3. Graph all solution for the inequality 3x minus 5 greater than x plus 2. So what do? We solve it like if it was just a equality. We solve it same way. 2 plus 5 plus 5. We have 3x. This cancel, and we have x plus 7 with our sign right there. We keep the sign. We do minus 5, minus x, I mean. negative x. So we have 2x greater than 7, right? And then we divide by 2. We divide by 2, and we have x greater than 7 over 2, or we can rewrite it as x greater than 3.5. And we do our graph. 3.5 is right there. Any number greater than 3.5 is solution. So 3.5 itself is not part. So we empty dot with a bold line pointing this direction, meaning all numbers greater than 3.5 to infinity are part of the solution. Let's do one more example 4, right? Example 4. And with the same type of question, graph or solution for 3 plus, no, let's do this one. X plus 4 greater or equal 5x plus 8. So we solve negative 4, negative 4, we have 4, this cancel, we have 5x, and we have x, and the sign still the same. And then we do negative 5x, negative 5x, this cancel, we have this side will give us negative 4x greater or equal 4. Now what do? We divide by negative 4, divide by negative 4. And pay attention at something here. I will have x and I will have negative 1. But now this sign will become less or equal. Why? Okay, let's open a parenthesis. When multiplying or when dividing by a negative number, here it was dividing by a negative number. When multiplying or when dividing by a negative number, the inequality symbol changes to its opposite. What does it mean? It means if it was less, it becomes greater. It was greater, it becomes less, right? If it was less or equal, it becomes greater or equal, and if it was greater or equal, it becomes less than equal. That's why here, because we are dividing by a negative number, dividing by a negative number, the sign here changed to the opposite. And this is what we will be using. This is the standard form. So we go ahead and graph it. We have negative 1. After negative 1, we have 0, 1, and so negative 2, negative 3. And what does it say? It says x is less or equal negative 1. That means negative 1 is part of the solution because we have equal there. So we put a bold dot, and x less than negative 1 is this side with our arrow pointing that direction. I think we can stop here. And so far we saw two methods of solving and graphing linear inequalities in one variable. And it will be up to you to know both methods and apply them at the right circumstances, or to know only one method and use it to all operations involving solving and graphing inequalities in one variable. Sometimes when we know more than one way of doing something, when there is a situation, you use the fastest way. You decide which way will be faster. So it's the same thing here. If you know the two ways of doing it, if you have a question, you will decide how am I going to solve it? What method am I going to use to get to the solution faster? That's why we have many methods of solving a problem. So I encourage you to know how to solve using different methods. And in this case, you have two methods available for you. So keep studying, and I see you for the next topic. Ciao.